You want to know how to make a 3D printed Ant-Man helmet? Well, let me show you how. Hey everyone, welcome back to the channel. My name's Luke, and in this video I'm going to be taking you through 3D printing an Ant-Man helmet, something like this. I'm going to be taking you through getting the files, editing the files, coding, electronics, and finally finishing a helmet, something like this. So the first thing to do is get some files. Okay, so the first thing we're going to be going through is the files. Now there's two places I'm going to recommend for this. The first being Do3D or Do3D. They have a plethora of different Ant-Man helmets, not Iron Man helmets. And this would be the main one. This is the one that I'm working on, which is the first classic one from the original Ant-Man film. But for this tutorial, I'm going to be using Walsh 3D's Ant-Man Mark 1 helmet. Now these files can be found on Wireframe 3D, along with two other options, but for this one I'm going with Walsh's just simply because of all the electronics, and I've had the file for about 2 years now. So we're going to now go and modify some of the files to then get everything printed. Okay, so now with the file all uploaded into Mesh Mixer, the first thing we're going to need to do is mirror all of the left hand side parts to the right hand side. And then once you've completed that, we're going to work on scaling the helmet. Now for me, I'm leaving it at 100%, but if you need to scale it or shrink it, whatever, do what you need. The final thing we're going to need to do is edit a couple of the files, specifically the right hand jaw and this the right and left antenna base. Now we're just going to edit these to add some holes into them. For the jaw, we're going to be putting a hidden button, and then for this little piece here, the antenna base, just a small enough hole to insert some wires into for the electronics. So let's go through that now. Alright, so now with the respirator joint imported into Mesh Mixer, we're going to go over to Edit and then Plane Cut. So essentially we're just going to be drawing a line right here between the two parts of the cap and the base is what I'm going to be calling them. And then you're just essentially going to be moving the plane around until you're kind of happy with how the button sits. You can stay here for as long as you want editing the file. I've already exported this, so that's kind of good enough to show. But then once you've done that, you're just going to keep slice and keep both sides. So we need to keep them both, or otherwise it will delete one side. And then just hit accept. And then go over to separate shells. And now it's separated the shells into three parts. But we're just going to hold shift and hold and highlight the main body, the ball, and whatever this little piece that we accidentally cut. Now with that done, just click combined, and there you go. So now we're just going to export both these files and then import the base into Tinkercad. Okay, so now with the file uploaded into Tinkercad, the first thing we're going to need to do is go over to this little corner and select box and make sure it's the one that's sort of grayed out. Now once you've imported that, you're going to basically want to put these measurements on. These are the optimal I found for this type of button, which is the one that comes in all the Arduino kits. So it should be 9.74 wide by 20.51 long by 7 mil high. Now I just found this gives enough room for soldering and wiring in there, and enough room for some hot glue and some wiggle room to articulate the button if need be. Once we've done that, we're just going to essentially take the box and insert it into the position we want it in the jaw. So I'm going to say here is pretty good. You kind of want it somewhere in the middle. I found works best. I've done a couple tests with this. And make sure it goes out the other side. And then once we've done that, we're going to hold shift and select the other object, and then go up here and select group. And there we go. So now Tinkercad has registered what we wanted removed, and it's removed it from the file. So all we have to do now is just export it, and then we can go off and 3D print it. Okay, so the other part that we're going to need to edit is this antenna base. Now obviously if you don't want to put electronics into the antennas, completely disregard this step. But it's the same principle as last time. We're just going to take one of these cylindrical pieces and just scale it down. I've just made a small little hole that I could just feed a couple wires through. So just play around with that, work around the magnets. So now let's go and 3D print all the parts and then have an overview on the electronics. And here we go. Now everything is 3D printed. This is because I wasn't going to be making a YouTube video, but here we are. So all the parts have been printed, assembled, electronics are in, which I'll go over in a minute. Everything's had a coat of paint and a couple rounds of filling. Alright, so let's talk about the eyes. Antman has some sort of unique eyes where you can see into it and you can see his eyes sometimes, compared to like an Iron Man helmet where you can't see into the eyes, it's just a blue strip. So you kind of need them transparent in both ways. So the easiest way that I was going to do this is resin print them, because I talked about this in an Instagram reel about making vacuum forms and like a buck and dyeing them, but that's super complicated and everything. But I also don't have a resin printer, and that's where Monocure 3D came in. They were super helpful and wanted to be able to help out with this project, so they resin printed the eyes and they look really good. So massive thank you to them. They have a bunch of resins that they make themselves, ranging from tough resins, durable resins, rubber resins. So I will leave a link down in the description so you can go and check them out for yourselves. They do offer worldwide shipping, so if you're interested in any of the products, please go and support them. So massive thank you to Charlie from Monocure 3D for being able to help out with this project. I also want to give a thank you to Melbourne Iron Man for being able to help out with this project. He resin printed all like the antenna base and the fan, because they were super small and I didn't want to sand them. So massive thank you to him for being able to help out with that. Go and follow him on his Instagram please, because he's making an incredible Mark 7 suit and it looks incredible at the moment, and it's not even painted yet. So massive thank you to him. So now let's go and do the electronics. Alright, and here is all the electronics in, all the LEDs and the servos, all powered by an Arduino Nano, connected to a custom PCB that I made. Here's a photo of it. I also have a YouTube tutorial on exactly how I built and manufacture all of the custom PCBs that I make. I will leave a link to that in the description if you wish to build one for yourself for this helmet or any other project you wish to have a PCB. So all the LEDs in this helmet are just 5-volt LEDs that come with all the Arduino kits. They look something sort of like this, which all just track back down through the jaws or back through into the sides, back into there where that little red light is, to the PCB that is mounted in there. The servos are just housed up the top, which are also connected to the PCB with our little hidden button already installed, which then opens up the helmet. So let's take a closer look just so you guys can get a bit of an understanding of exactly how this looks inside. So as you can see just here, the button is mounted up here and its wire tracks down to a little hole that I drilled through the plastic, and then the antenna and its antenna base wires both come through. Exact same happens to the other side. Antenna and antenna base lights come through here, and the respirator lights come through this hole, which track through there, down and then into there. Both servos also mounted in with their wires coming through, joining up with JST connectors and then mounting into the board. Then the board is also mounted on a little 3D printed plastic base, and it is just friction fit in there, and then that way it stays out of the way and it's nowhere mounted behind my head. The ears are deep enough that they actually fit the board in perfectly for me. So now with all of those done, we will now have to disassemble the entire thing and get it ready for paint. Alright, so let's talk code, probably the most daunting part of this entire build. Personally, I suck at coding despite using Crashworks' incredible code. I still don't really understand what I'm doing half the time. So yet again, massive thank you to Melbourne Iron Man for helping out with fixing the code, because I still suck at it. So essentially the first thing we're going to need to do is download Crashworks Iron Man code. I'm going to leave a link to the GitHub in the description, where you can just go and download it and then export everything from the zip file. So we're going to go into the Iron Man servo and then to Iron Man servo code. And then once we're met with that, we'll be probably met with this screen. So up top is the config.h where we're just going to be changing one part, but it's where everything is sort of listed, so all the parts that we need. So if you wanted to add other LEDs into this helmet, if you wanted to add a little fan where the fan goes, or something like that, go for it. And then the main body of code, which is Iron Man Servo. So the first line of code we're going to want to write is down here at around line 120. Now it's going to be different for everyone, but just look for eye left pin and right eye pin. This is in pins 6 and 3, but we're just going to be adding hashtag define blink LED 5. Now this is going to be controlling the LEDs in the antennas to blink on and off. Once you've done that, we're just going to jump back over to Antman servo, which is the main body of code, and scroll all the way down to around line 827, I think it was, to around this end, so just above void setup. Now in here, we're just going to be wanting to put this big chunk of code. This is going to be talking to the board about our LED blinking on and off. Now for the coding people who might be watching this video, you could be just going, oh, why don't you just add it as a delay in the loop? I originally tried that, and then the code had a massive problem with the button having masses of problems. So the way that we got around this was LED blink without delay. So this is essentially just remembering what the LED did last time and just repeating it over and over again. It's probably not the easiest way to do it for people who are new to coding, but this is the only way we were able to get it to work with the button and the servos and everything. But that is going in between this end little bit and void setup. We're also going to scroll down into void setup now and just paste in this little bit of code at the bottom. Hashtag if define LED, which links back to our LED 5, so that little one in the config.h. And we're just going to put pin mode, pin LED output. So it's just telling this code, hey, there's an output, watch out for it, and then end if. Once that's done, we're going to scroll all the way down into the void loop, and just here, this is the code that you'll need to paste in. So this is just telling it to go over and over and over and over again, to be just constantly checking what this LED wants us to do and checking how it wants to run into line 886, somewhere roughly around there. Just make sure it's under the missile in void loop. The last remaining bit after all this is done is scroll up back to where we did just above the void setup, and here, this line of code allows us to edit the delay between when the LED is on and off. I've set it to 1.5 seconds. You can change it to whatever variable you want. Just remember it works in milliseconds, so yeah. Now after all that's done, we're going to go up to here and hit verify, and there we go, done compiling, and it is perfect. So now you can just plug in your Arduino and plug it in and then upload the code, and there we go. Alright, so let's talk about the paint. This is probably the most fun but hard part to any project, but if you take your time, you'll be more than fine. The first thing we're going to need is a base coat. For this, I'm using Rust-Oleum 2-in-1 filler and sandable. This stuff's super easy. It's in a can, which makes your life easier. I'm just going to coat this on quite heavily just to try and fill some of the layer lines, along with some filling and some wet sanding on top of that to get everything super smooth. The next thing we're going to need is a gloss black base coat, as I'm going to be using a Lumiluster on top for my chrome. An Lumiluster is going to need a gloss black base coat. Same goes with any chrome paints. So for this, I'm just going to be using Rust-Oleum's gloss black. This stuff's super easy to use, and it's in a can, yet again making your life easier. I could have used a gloss black base coat in an HVLP gun, but I was interested to see if I could get the same results in a rattle can, which you indeed can. The next thing we're going to need is a flat black. This is around the ears on the helmet. Simply for this, I'm just going to be using SMS's Surface Black. It's a flat black. It goes on with an airbrush, so not everyone's going to be able to do this, but a substitute is just Rust-Oleum flat black in a can. This stuff's super good. You just need to tape more. I have more control with an airbrush. I can adjust it easier, so it might look better, but if you do a good enough taping job, this will do just fine. The next thing we're going to need is the red. Now Antman's got some red on his ears and on the faceplate, so for this I'm just going to be using SMS Clear Red. The reason I've gone with the clear red is because I can add more paint to make it darker or add less paint to make it lighter. This is through an airbrush, so not everyone's going to be able to use this, but the substitute is just Duplicolor Metal Cast Red. This stuff's super good, and because you're going to be putting it on a chrome base, it will be super shiny, not dull. The next thing we're going to need is the chrome. Now, like I said, I'm going to be using a Lumiluster for this, but not everyone's going to be having access to that. So I would just use like a chrome and maybe a pearl and some splattered black to sort of give it that metalled effect. Take your time, experiment with that. I can't guarantee it's going to work, but this one's just a cheap, easy option to use. And lastly, a clear coat to seal off everything. Now, you can use a can, but because in Australia we don't have a 2K gloss clear coat, this is just a 1K, I want this to be shinier, so for this I'm going to be using MS22 2K clear coat. This stuff has to go through an HVLP gun. It's super easy to use. I've used it before on the Hallmark 2, but this is my substitute to a 2K clear coat. I believe this is the correct 2K clear coat by the Duplicolor range. But yes, other than that, that is pretty much all the paint there is. And now, let's get to painting the helmet. Now all of the parts are wet sanded up to 2000 grit. They are all pristine smooth and ready for the gloss black. So I'm just about to glue on these sticks just to hold all of that smaller parts, so the iframe and all the scales. And then once they are gloss black, we'll hit them with a coat of Lumiluster and then another 2K coat over that. And then we'll be ready to then reassemble it. But I am quite happy with the black. So this is sort of what we're gonna get in the end, fingers crossed if I do it correctly, and then yeah, we're on track. And well, the helmet is now complete. I'm super happy with how this turned out. The Lumiluster looks amazing, along with the red accents and the black accents. That's sort of also why this helmet took a lot longer, is the paint finish. I tried to do a better job than the last time I ever did this, which was along with the Mark II with its Lumiluster finish. But that's always the way with projects. You're just always going to try and do better than the last one that you did. So I'm super happy with how that turned out, along with the custom PCB and the hidden button and the blinking LEDs, along with the motorized helmet. All the electronics look amazing and sort of bring the helmet to life even more. I'm super happy with the eyes that Monocure 3D was kind enough to do for me. They definitely add the realism to the helmet to make it even nicer than what it was. And a massive thank you to Melbourne Antman for helping out with the resin printing and a little bit of the coding, because I still don't understand code and it will never make sense in my life. So thank you so much for watching this video if you made it this far. And now, time for the final result.